Hi everyone. The discussion is about analysis of test data in rubber lab. Myself, Dr. G. Sarojini, Associate Professor, Department of Chemical Engineering, Hindustan College of Engineering and Technology. The function of the analyst is to obtain the result as near to the true value as possible by correct application of the procedure employed. The level of confidence will be very small unless the knowledge of the accuracy and precision of methods and the sources of errors are known. So let us discuss the terms employed and the statistical procedure employed to analyze the test data. So we will be discussing what is the classification of error, what is accuracy, precision, how to minimize error, and what is the statistical analysis of test data, and then what is the importance of reporting and documenting the test data. So error which occurs due to experimental nature or analytical nature is classified into two types. One is systematic error, another one will be a random error. Systematic error is commonly occurring error, whereas random error it occurs uncommonly. Systematic error, in this type of error, magnitude of error can be determined and this type of error can be avoided. The most important them are operational error, personal error, instrument and reagent error, errors of method, additive and proportional error. So operational error, the individual analyst is responsible for this type of error and also not connected with the method of procedure. They form the part of the personal equation of an observer. These errors are mostly physical in nature and occur when the sound analytical technique is not followed. Examples of operational error includes mechanical loss of materials in various steps of an analysis, underwashing or overwashing of precipitates, ignition of precipitates at incorrect temperatures, and insufficient cooling of crucibles before or during weighing. The next one is the personal error. The personal error may arise from the constitutional inability of an individual to make certain observations correctly. Thus, some persons are unable to judge color changes sharply in visual titulations, which may result in a oversight stepping of the endpoint. Next, the most common error is the instrumental and reagent error. These errors arise from the faulty construction of balances, the use of uncalibrated or improperly calibrated weights, graduated glassware, and other instruments. Examples are the attack of reagents upon glassware, porcelain, resulting in the introduction of foreign substances, which gives the error wrongly, and then volatilization of platinum at a very high temperature, and the use of reagents containing impurities. Then the errors of method. These errors of method originate from incorrect sample and from the incompleteness of the reaction. In gravimetric analysis, the errors may arise due to appreciable solubility of precipitate, co-precipitation and post-precipitation, decomposition or volatilization of weighing forms on the ignition and precipitation of other substances other than the intended ones. In cytometric analysis, the errors may owe occurring to the failure reactions to proceed to completion, the occurrence of induced and side reaction, the reactions of substances other than the constituent being determined, and the difference between the endpoint and the stoichiometric equivalence of a reaction. Additive and proportional error. The absolute value of an additive error is independent of the amount of constituent present in the determination. Examples of additive errors are loss in weight of a crucible in which the precipitate is ignited and the error is in weights. The presence of these errors is revealed by taking samples of different weights. The absolute value of a proportional error depends upon the amount of the constituent. Then, the proportional error may arise from an impurity in a standard substance, which may lead to the incorrect value for the molarity of the standard solution. The next type of error is random error. These errors manifest themselves by the slight variations that occur in successive measurements made by the same observer with the greatest care under as nearly identical conditions as possible. They are due to causes over which the analyst has no control and are so intangible that they are incapable of analysis. If a sufficiently large number of observations is made, it can be shown that these errors lie on a curve. An inspection of these error curve shows small errors occurs more frequently than larger one, and then positive and negative errors of the same numerical magnitude are equally likely to occur. Accuracy. Accuracy of the determination may be defined as the concordance between the real and the true or most probable value. Systematic error can cause a constant error, either it may be too high or too low, and then thus affecting the accuracy of a result. For analytical methods, there are two possible ways of weighing the accuracy, that is absolute method and then comparative method. So in absolute method, the difference between the mean of an adequate number of results and the amount of the constituents actually present, usually expressed as parts per thousand, is a measure of accuracy of the method in the absence of foreign substances. In comparative method, the comparison between several test data will be made. Precision. So precision may be defined as a concordance of a series of measurements of the same quantity. Accuracy expresses the correctness of measurement, whereas the precision gives the reproducibility of a measurement. Precision always accompanies accuracy, but a high degree of precision does not imply accuracy. And then there are some ways to minimize the error. First one will be the calibration of apparatus and the application of corrections. Second one, running a blank determination. And third one, running a control determination. And fourth one, use of independent methods of analysis. And fifth one, running parallel determination. Sixth will be your standard addition. Seventh will be internal standard. And eighth will be amplification methods, and the last one will be the isotopic dilution. Among those methods to minimize the error, the calibration of apparatus and the application of correctness is usually employed in all experimental procedure. So here all instruments, for example weights, flask, burettes, pipettes should be calibrated and the appropriate corrections applied to the original measurements should be done. In some cases, where an error cannot be eliminated, it is possible to apply the correction for the effect that it produces, and thus the impurity in the weight precipitate may be determined and its weight detected. So after going for error minimization, we have to go for the statistical analysis of test data by means of comparing significant figures and by means of applying procedure of mean and standard deviation, by distribution of random error, reliability of test, comparison of result. So after performing statistical analysis, it is essential to document the data which we are analyzed. So the purpose of documentation is reviewing the test data. So first, for creating record for any process outcome which can be retrieved in case of any requirement such as fault failure. Example, process parameter report. And then for creating a record of any process outcome which need to be shown to supervisor, for example, part inspection report. And then for creating record for any meeting outcome which can be retrieved in case of any dispute later on. Then for reporting to external agency, for example, filling waste disposal report to Pollution Control Board. For procurement of quality materials by avoiding the sources which supplied the bad ingredients in their last supply. Also for follow-up analysis, whatever is required from time to time, and for the rectification of the machine and accessories which were in operation when the defects had occurred, and also for retaining the operators who were operating the machines when defects were occurred, to change the standard operating procedure to avoid reoccurrence of the same defects, and then to plan for adaptation of new processes and plan the equipment. Lack of record maintenance will result in breakdown of monitoring system. To create traceability record of the maintenance of the material produced or tested. Then the purpose of reporting. So it is after documentation, it is important to report. So in any organization, reporting is important. Based on reporting, only senior management remains aware of day-to-day activities. It also helps in management taking corrective action to run the operation as efficiently with good quality and minimum rejection, as it is very essential for making improvements in operation. For example, through reporting, only management shall come to know any shortfall in production. Reporting is necessary to run operation as well as it is very essential for making improvements in operation. For example, through reporting only, management shall come to know any downfall in production. Based on the reporting only, management can take some action to improve the productivity. Thank you.